SolidWorks provides an extensive library of material types that can be added to parts. The edit material dialog is used to add and edit the material associated with the part. The material is used for calculation that rely on material properties, including mass properties and simulation express. Each material also updates the appearance of the part in the graphic area, which is enhanced by turning on real view graphics. The material can vary by configuration, and custom material can be created using a preloaded material as a template. In this tutorial, I'll add two different materials to a water bottle. Once the first material type is added, I'll create additional configuration and add the second material. Then I'll walk through how to create a custom material, adjust the material properties, and then apply the custom material to the part. Here I have a water bottle that has no material applied to it. Water bottles are often created using the either metal like stainless steel or plastic material like high density polyethylene. I applied to each material to the water bottle beginning with stainless steel. The material of the part is listed in the feature manager tree. Currently this part has no material applied to it as shown by the text not specified. If I right click on the feature manager tree, a list of options become available. If I select the first option, edit material, it will prompt the material dialog box and it's set to the properties tab. This lists all of the available materials that are preloaded into the SolidWorks database. I'll click close for now. The second option, configure material, will bring up the modify configuration dialog box, which allows different material to be applied to different part configurations. Additional configurations can also be created here. I'll click cancel for now. Manage favorite controls, which materials are shown below for quick access in this right click menu. If I click manage favorites, it will bring up the material dialog box as well. However, I pre-select the favorite tabs where the materials can be chosen and arranged in the list. If certain material types are used frequently in your designs, such as specific plastic or metal, it's good to add them to this list to make them quickly accessible for future use. I'll close to the exit dialog box. To add stainless steel as the material type for the water bottle, I'll right click on material in the feature manager tree. Click edit material and in the material tree on the left. I'll make sure to expand the steel library. A list of various steel types appear and I'll click on the type ASI 304. The table on the right populates with all of the material properties characterizing this metal, such as material elastic modulus, the density of the material, its tensile strength, and the material thermal conductivity. These values can be adjusted when a custom material is created, which I'll cover little later in this lesson. For now, I'll click the apply button at the bottom of the dialog box and the material is applied. I'll click close to exit the material dialog box. Notice that the material is now listed as ASI 304 in the feature manager tree, indicating that this is the currently applied material. The appearance of the part also changes the graphic area according to the material type. I'll click on the view settings drop down menu in the heads up toolbar and enable real view graphics to give a better depiction of how the appearance is affected by choosing a material. The part now has polished metallic appearance. Now I would like to switch the material to a high density polyethylene. Instead of simply swapping out the material type, I'll add new configuration with the polyethylene material. I'll right click on the material in the feature tree, click configure material, and the modify configuration dialog box appears. In this window, I'll type the name plastic as the name of the new configuration. And in the material column, I'll click on the drop down arrow, scroll down and select browse more. And the material dialog box appears. I'll need to minimize the steel folder to view other available material libraries. Now I can see the folder labeled plastics, and when I expand the folder, there is a material listed called PE high density. I'll click on this material, click apply and click close to exit the material dialog box. Now this material is set for this new configuration. If I click OK to exit the modify configuration dialog box. Now if I go to the configuration tab, the new configuration plastic is listed. And when I double click on it, the part appearance updates in the graphic area. I'll switch back of the feature tree and the material is set to PE high density for this configuration. Although a SolidWorks provides an extensive library of pre-loaded materials, it may be necessary to apply a material to be part that's not found in the material library. In this case, custom material can be created and added to the library. This is done by copying a material to a custom library and then changing the copy properties. To begin creating a custom material, I'll right-click the material in the feature tree and select Edit Material. I want to create a material that's similar to the high-density polyethylene set of the part, but with a lower thermal conductivity. So I'll right-click to the PE high density in the list and select Copy. Alternatively, I could click on the material in the list and press Ctrl C on the keyboard. Now I minimize the plastic folder in the material tree. And at the bottom there is a folder titled Custom Materials. I'll expand this folder and I'll right click on the folder plastic and select Paste from the menu. Now the material appears in the list. I'll rename this material by right click on the menu and selecting rename. I'll call this material PE reduced. Now that the part is renamed, notice that the value column in the table is not shown in gray, meaning that these values can be edited. In this case, I need to refine the thermal conductivity specific to this plastic. So I'll click on the value for the thermal conductivity and enter a value of 0.432. There is also drop down arrow the right of the cell, which has options to temperature dependent and leak parameters. In addition to material properties, I can switch off the appearance tab to edit the aesthetic look. Checking the apply appearance of the checkbox will apply visual properties to the part based on appearance setting below, while deselecting this box will only apply the material's physical properties. Note that you can only modify the appearance of custom materials, not default materials. I will leave this checked, and in the appearance section below I can choose an option from a variety of folders in the appearance tree, or use the custom color controls on the right to specify a new color to apply. I can use the drop down to filter by grayscale shades, pastels or standard colors, and I can choose whether to use the custom material optical properties. Notice that selecting any of these color in the palette will update the color swatch above the custom colors drop down. While selecting an appearance from the tree on the left, update both of the color swatch and the material preview in the lower right corner. For this example, I'll select the big high gloss plastic option from the high gloss subfolder to the plastic folder in the tree. Leave the optical properties checkbox clear, and when I click apply, you can see the part appearance has updated in the graphic area. Now that I have applied changes to the thermal conductivity value and appearance settings, I'll click close to exit. And this material is now set to PE reduced in the feature manager tree.